We've talked before about shifts and transformations for other types of functions, but today we're going to talk about how to do it with rational functions. So when the parent function is 1 over x. The good news is the rules for what a, b, c, and d actually do is the same. But the only difference is it just looks a little bit different because we're dealing with a fraction. So really, the only thing you have to think about is you need to think of what we called the inside of the function as the denominator. Because before we had things inside of a fraction, inside of a square root, inside of a trig function, things like that. This time it's inside the denominator. So in what you see here, the bx plus c is what's on the inside, and the negative, the a, and the d are what's on the outside. So that's really the only difference you have to worry about remembering. If the negative, or the a, or the d, you treat on the outside, the bx plus c, you treat as the inside. But if you look, and just so you know, I'm going to read through these, and if you need to pause this so you can write this down, you feel free to do so. A negative is going to be either outside or on top. Either way, if a negative sign is outside the fraction to the left, like it is in what I wrote, or if it's on top right in front of the a, either way, it reflects the graph across the x-axis. Now the letter a, which is on top of the fraction, just like it did before, it stretches the graph vertically if a is greater than 1, and it compresses the graph vertically if a is less than 1. And then here are the rules for b, c, and d as well. They are the same as they were before. b and c are both on the inside because they're inside the denominator. So b stretches us horizontally. It does feel backwards because it stretches us horizontally if it's less than 1 and compresses us horizontally if it's greater than 1. Then c shifts to the left if we're adding the c, and shifts to the right if we're subtracting the c. So b and c are just like before, part of the inside part that does horizontal things. Stretching, compressing, shifting left or right. And then d, which will always be written out to the side, it shifts us up if we're adding d, and down if we're subtracting d. So all the rules for a, b, c, and d are the same as they were before. Now the thing I've circled is the one difference, because we had not talked about asymptotes in conjunction with this before. But it turns out that d, whatever d is equal to, is our horizontal asymptote. You can find vertical asymptotes just like we did before. You set the denominator equal to 0, and as long as that number does not also make the numerator 0, it's a vertical asymptote. But for horizontal asymptotes, it turns out that d is the horizontal asymptote. So we'll talk about that as we go through some examples. But one thing I want to go ahead and tell you is that if there is no d, there still is a horizontal asymptote. Because if we don't write a value for d, that means d is equal to 0. So for that one, the horizontal asymptote would be equal to 0. Again, if you need to pause this to write things down, go ahead and do so, because in just a second, I'm going to transition to the next slide and do some examples. Excuse me. So the first one, we're adding 5, and we're doing it inside the denominator. Since it's inside the denominator, I know it has to be to the left or to the right. And since we're adding, I know it's to the left. So this would be shifting left 5. Or we should write shifts left 5. Okay, for the second example, we have two things happening. We have a negative, which is going to reflect it across the x-axis. and we have the 2 on the bottom. It's inside the denominator, so that means it's a horizontal change. Since it's greater than 1, it's a horizontal compression. So the 2 makes it horizontally compressed. For our third example, the 4 over x minus 3, the 4 is in the numerator. Anything in the numerator or out to the side, left or right, is on the outside. So the 4 is a vertical change, and because it's greater than 1, it's a vertical stretch. And the minus 3 is in the denominator. So that's inside, it's inside the denominator, so that's a shift to the right since we're subtracting, so it shifts right 3. And of course, save the best for last, have a whole lot going on here. We've got 4 things happening. We've got the negative, we've got the 6, we've got the plus 2, and the minus 4. So the negative, just like we said before, reflects us across the x-axis. So that's what the negative does. The 6 is outside the denominator. Sorry if it looks like a b, but it is a 6 on top of the fraction. The 6 will stretch us vertically. Just a quick reminder, you treat the negative and the 6 as 2 completely different things. So, at least the way I have written it, A is just the 6. The negative is what reflects us. The 6 is what stretches us because 6 is greater than 1. So the 6 stretches us vertically. So that takes care of the negative and the 6. The plus 2 is inside the denominator, so it means we shift to the left 2. And the minus 4 is outside, off to the side. It shifts us down 2. Sorry, down 4. Didn't use that. The minus 4 shifts us down 4. So I do want to pause a second because we've been talking about asymptotes and talk about the horizontal and vertical asymptotes for a moment. So for the vertical asymptotes, like I said, you just look at what would make the denominator equal 0. So for the first example, it'd be negative 5 for the vertical asymptote. It'd be 0 for this one. It'd be 3 for this one. I'm sure we're at the 3, sorry. And negative 2 for the last one. So the vertical asymptote is really the same as what we talked about before. What will make the denominator equal 0? The horizontal asymptote is whatever d is equal to. So in this last example, we get the horizontal asymptote from this. So y equals negative 4 is the horizontal asymptote. Whereas in all of the first 3, you see there is no d that shows up. But that just means that d is equal to 0. So for all 3 of these, the horizontal asymptote would be y equals 0. So you've got to remember that with these, in this form, the value of d is the horizontal asymptote. So there's your homework. For those of you in my class, good luck.